Hello everyone, today I'm going to introduce a fantastic topic in physics, which is motion. Firstly, time, distance, and displacement will be introduced by me. Next, Paco will present scalars and vectors. Lastly, Marcus will illustrate the most interesting topic, which is speed, velocity, and acceleration. Let's begin a fantastic journey. Time is crucial for the calculation of motion, representing the specific point or period when an event occurs. For instance, the duration for which you watch a video is quantified as time. Calorimeter stands out a prime example of how positions, velocities, and accelerations evolve over time. Scientists quantify time using the second as the SI unit. Distance and displacement are essential for further calculation of motion. Let's talk about distance. Distance measures the length between objects or points without direction, and it can be calculated in meters. Let's give an example. In this example, the total distance that the car traveled can be calculated by adding the lengths of two segments of the journey together. Therefore, the total distance traveled by the car is the sum of these two segments. The total distance is equal to 100 meters to north at 3 meters to west to east is equal to 400 meters, which means distance. The definition of displacement means distance measures the difference between the final and initial position of a point in a straight line, and we will measure it in meters. Displacement is the change in position that an object undergoes relative to a reference frame when it moves. It considers both the distance and direction traveled, unlike distance, which only measures the total length covered. And now we are going to discuss a fundamental concept in physics, displacement. When an object moves in relation to a reference frame, its position changes. For instance, imagine a professor walking to the right in front of a whiteboard. In this scenario, the professor's position is shifting relative to the board. Similarly, consider a passenger moving toward the rear of an airplane. As the passenger shifts their position, they are also changing their location relative to the cabin. This change in position is what we call displacement. It's a crucial concept that helps us understand motion and how objects relate to their surroundings. So, whatever is it a professor, a passenger, or any object, when movement occurs relative to a fixed point, we can measure that change as displacement. This is the end of my part. Thank you.
Now let us talk about calculating different directions of displacement. For example, consider a person going on a trip from point A to point D. To find the total displacement, we need to determine the shortest distance between A and D, which is crucial for understanding how far the person has moved from their starting point. First, we need to find the lengths of segments AB and BD. In this scenario, AB measures 14 kilometers, while BD measures 16 kilometers. Next, we apply Pythagoras theorem to find the length AD, which represents the direct line from point A to point D. According to the theorem, we calculate the square root of the sum of the square of AB and BD, leading us to find that the length of AD is appropriately 21.3 kilometers. Finally, after calculating both the distance and the direction, we find that the total displacement. In this case, it is 21.3 kilometers with a bearing of S 48.8 degree E. This comprehensive approach allows us to visualize the movement and understand the relationship between the different segments of the journey. In the first section, we will learn about scalar and vectors. A scalar is a physical quality that is completely described by its magnitude. For example, volume, density, distance, energy, mass, and time. Scalars are usually described by real numbers, but they are not necessarily positive. A vector is a quality that has both magnitude and direction for a complete description. Examples of vectors include displacement, velocity, and acceleration. Vectors are typically represented by an arrow, indicating their direction. The key differences between them is direction. Vectors have direction, while scalars do not.
Then let's talk about speed and velocity.
What?
Speed is a measure of how fast an object moves. The definition of speed is distance traveled per unit time. This means rho is needed in calculating speed, and it is a scalar and does not tell us the traveling direction of an object. It has just magnitude but no direction. The SI unit of speed is meter per second. The example of speed is a car traveling at 60 kilometers per hour. We say that the speed of a car is 60 kilometers per hour. The velocity can tell us how fast and in what direction an object moves. It's a vector. It has both magnitude and direction. The SI unit of velocity is m per s. The example of velocity is a boat soars towards the east with a speed of 10 meters per second. We say that its velocity is 10 meters per second due east. Second, we'll talk about average speed. Average speed is an overview of how fast an object moves over a whole journey, and it does not tell us the variation that may occur during a journey. On most occasions, the speed at any instant is different from the average speed. That means the average speed is just an overview, and average speed can be calculated by this formula: total distance traveled divided total time of travel. And instantaneous speed is the speed of an object in any instant. For example, the speedometer of a car shows the instantaneous speed of the car. An average velocity is slightly different from average speed. It can show how fast and the direction of an object moves. The average velocity is given by total displacement divided total time of travel. The instantaneous velocity is the velocity of an object at any instant. The direction of instantaneous velocity is the direction of motion of an object, showing where the object is heading at a certain instant. The example is the velocity vector of a boat change as it moves along a circular path. And next part, I will talk about acceleration. Acceleration is the change in velocity per unit time, and it is a measure of how fast an object changes its velocity. And the SI unit of acceleration is meter per second squared, m per s squared. An object has an acceleration whenever its velocity changes, and there are three situations: speed up, slow down, or change direction. And when an object's velocity changes over a time period, and there is an average acceleration of this travel, and it can be calculated by this formula: total change in velocity divided total time of travel. And it can show the average velocity change over the time period.
At the end of the lesson, let's discuss the final motion. The direction of velocity and acceleration affects the final motion. First, we need to take the direction to the right as positive. When the velocity and acceleration are in same direction, that means they are both positive, or they are in both negative. The final motion will speed up. If the velocity and the acceleration are in different directions, that means one is in positive and the another one is negative. The final motion will slow down. Today our lesson ends here. I hope you all grasped the materials. Thank you for watching.
And research some data from those pages. Firstly, Sprinter Science. Secondly, research some data from our book, Physics at Work, Shutterstock, Science Facts, Mathematics pages, and Young. Lastly, your dictionary pages help us to know about the examples of vector and scalar physics. Thank you all for watching our video. If there is something wrong about our resources, we regret about that. Lastly, we thank you all for watching our video. We are first making this video, so we ensure that there are much things wrong in this video. We give a big hand for you guys and see you soon. Bye bye.
Always being true to me, and thank you being so loyal and true. I don't know where I would be if I would lose you, so I gotta say it thank you. I wanna break it down for you. Snap your fingers, do the step. Snap your fingers, yeah. You're my love, my body and soul. When you're ready to rock, I'm ready to roll. And if you feel like you wanna fly, come and ride with your boy, let's go. I'ma give you everything that you want. Cop you plenty, get down with the flop. Dolce & Gabbana, the Louis Vuitton, baby girl, listen to the words of the song. Every time that I would feel